I am doing the design in Arduino based emergency light system which measures the battery voltage, the grid status and the room light intensity, as well as we have to test input for it. So as you can see, this is how the final product looks like. I have my USB cable here which is coming from the Arduino Uno Offrey. This is my 12 VAC DC 5-watt bulb, and I didn't stick it on purpose so that we can increase its length according to what the client wants. So as you can see, we have 3 LEDs. One is green, one is yellow, and one is red. They turn on specific conditions. On this side we have a test button here. It is meant to test input. I will be explaining each of these components' purposes later on in this video itself. And from this side, as you can see, there are 2 connections meant to be connected to the power supply. One is positive, green is positive and black is negative in this case. And this wire over here is meant for the battery charger, which goes straight into the wall power supply. And on this side over here we have an LDO. This is meant to record the room light intensity. I will now go for this brochure as if you are my client. Please note this is a new brochure and I have updated it as per the TA's remark from the last submission. So as you can see, we have an image of the final product over here. And to watch the video, you can simply scan this QR code, or you can just write the link over there. The whole purpose of the Arduino Arduino project is to turn on the emergency light when there's power failure. It detects grid status, room brightness, and battery voltage to determine when to activate the emergency light. For the component specifications now, we have a current sensor rated 300 volts 10 amps. It is used to measure the grid status. The current sensor is right over here, followed by a voltage sensor which is 300 volts 10 amps. It is used to measure the battery voltage. And now we have a relay which is rated 10 amps 250 VAC. The purpose of the relay is to turn on the emergency light based on the conditions of the code, and it automatically charges the battery through the battery charger when there's no emergency light on. I've also used a voltage regulator, WL7809, rated 9 volts 1.5 amps. It is used to simply convert 250 volt from the wall power supply into 9 volt, which then goes into the Arduino, making sure the battery charger is getting enough voltage from the power supply and it's not burning any Arduino. It's not burning the Arduino. The battery over here is 12 volt 7.0 AH, and the battery charger is 13 amps 1.5 milliamps. The battery charger charges the battery when it discharges. The bulb over here is rated 12 VAC DC. It's also 5 watts. This is the emergency light basically. And my Arduino Uno R3 rated 5 volts, followed by my LDO, which I've already told you earlier. It is connected to the 5 volt VDC of the Arduino. I will now go over the specifications of the enclosure. So it measures 11.8 by 9.8 by 4.7 inches. Its weight is 0.55 ounces, and it consists of 10 ventilation holes, which I have poked here to add the LEDs and other equipments, the connections of other equipment. There are 10 in total. And now I'll explain all of the connection details, which will make sense as the video progresses. For the connection details now, we can see that the relay module is connected to pin D7 of the Arduino, and it helps to control the emergency light based on system logic. So as you can see, this blue wire right here is connected to D7, followed by the voltage sensor, which is connected to A0. Voltage sensor is right there, it's connected to A0. And we have the current sensor, which is connected to A1. And we have the LDR connected to A3 and the test button, which is connected to D2 of the Arduino, as shown in this connection below. So the test button goes to D2 and the LDR goes to A3. On this side we have three LEDs, one green which turns on when grid is on and room is bright. Yellow LED turns on when there's low battery or some connection problem. Red LED turns on when there's grid off and the room is dark. They all serve their own purpose and you'll understand better later on. As you can see, everything that I've just told you is written here, and later on I'll prove it when I'm running the product. The key features are it gives you low battery warning with the LED indicator. There's LDO based room brightness detection, relay control emergency light system, and manual test button for system override. So how does it work? The current sensor detects grid status when the power supply is turned on, and the LDR constantly checks for the room brightness level. If the grid is off, meaning there's no power supply and the room is dark, the relay turns on the emergency light. If the battery voltage is low or there's a connection problem, a yellow LED alerts the user, and the test button allows the user to manually turn on the emergency light. Before I go through the code, I'll give you a demonstration of how the product works. As you can see, once I remove the battery connection, the yellow LED turns on, meaning there's some connection problem or it might not support emergency light for a longer time. At the same time, through my code and the Arduino IDE, you can read what's happening. So as you can see, I remove the connections, there's no battery voltage, and the yellow LED did turn on. I'll connect this back now. And now we'll proceed with turning the green LEDs and the red LEDs. Usually we have to put screws in all of these holes over here, but just for the demonstration I didn't do it. And this wire right here is meant for the battery charger, which charges the battery. It will go straight in the wall power supply. Now I will be making a connection with the power supply to this junction box. So black wire goes to the ground and the green wire goes to positive. I have a power supply here. I'll be outputting 0.8-0.9 amps into the circuit, and this multimeter is being used as an ammeter for me to measure how much current I'm putting into the system. So green wire, as I said, is positive. So now I'm set to power the system and to check if there's grid available and not to have any grid, and to check if there's grid or if there are no grid available. For the green LED to turn on now, we have to make sure there's grid available, and meaning there's current flowing from power supply into the system, and the LDR is constantly measuring the room light intensity within the range. To demonstrate how the green LED works, there are two conditions that should be met. There should be current flowing from the power supply, indicating there's grid available, and the light intensity, which is being measured by the LDR right here, gives us a value which is within the range of the threshold. At the same time, everything is being monitored on the Arduino IDE over here. So there's no grid right now, and the light intensity is 118. I will now be outputting 0.9 amps into this box, and since there's grid now and the light intensity is within the range, the green LED turns on. To demonstrate how the red LED works, there should be two conditions to be met. So first of all, there should be no current flowing from the power supply, which means there are no grid available, and the light intensity should go beyond the threshold range, meaning the room is dark and therefore an emergency light should turn on. To demonstrate this, I'll stop outputting power over here. So from the code it says grid is off because there's no power. And I'll turn on this light here. So there's no grid available and room light intensity is beyond the range. So the emergency light turned on. And the red LED is on too. The test button overrides all situation and it should still turn on the light. So I'm pressing the button right here, and as you can see it keeps on saying the emergency light on. Now if I remove if you notice the battery voltage right now, it's not charging since the emergency light is on. But if I add grid to it, you'll also notice it starts going above 12.37 volt, which means when there's no emergency light, the relay automatically charges the battery from the battery charger, which I showed you earlier. We will now go for the code that has been running the entire system as shown earlier. So the serial monitor was used to display the results from early testing. I'll just close this now and have more space for the code. So first of all, I've defined my pins. So define relay to 7, so it goes to D7. The voltage sensor was also assigned to a pin, the current sensor assigned to a pin, and room light sensor was assigned to A3. The test button was assigned to A2. For the LED pins now, we have 3 of them, red, green, yellow. Each of them have been assigned to 5, 4 and 3. We needed 3 thresholds, so one for the battery, which is 10.5, another one for current threshold for the grid status, and a light intensity threshold for the room light intensity. And now over here we're just setting up the void setup over here. So pin mode, V sensor, current sensor, room light sensor. I am simply setting them as input pins, and then I'm setting the test button and the input pull-up resistor as an input. So it means that the default state is high for 5 volts. When pressed, the pin goes low, connected to ground. For pin mode, relay to yellow LED. For pin mode, I'm just setting them as output, and digital write, it simply means that everything turns off initially to avoid anything switching on unexpectedly when the system powers up. And serial beginning 9600. Serial beginning 9600 simply means starts communicating with my computer basically at 9600 baud rate. Used for it is mostly used for debugging and showing sensor readings and LED in the serial monitor at specific time interval instructions. So battery voltage is equal to get battery voltage. The function means all of this part over here. They are used to get real-time readings from the battery voltage, the grid current, the room brightness, and if the test button has been pressed. Over here we had a condition, if it's less than if the grid current is less than 0.6, it means the grid is considered off, otherwise grid is considered on. Now if the grid is on and the room is bright, green LED turns on to show that the system is in normal mode. And if the room, and for this one, if the grid is off and the room is dark, it simply means the red LED should turn on to indicate emergency light system. For the yellow LED to turn on now, if the battery voltage drops below 10.5 volt, the yellow LED turns on as a yellow battery, turns on a yellow warning, a yellow battery warning, which I've already showed you which I already shown in the previously. And the emergency light relay turns on only if the grid is off and the room is dark. Otherwise, it stays off, and the green LED should be on. And now this is just the way I've printed my. It's just a way of showing how the grid current, the battery voltage, the test mode, the red, green, yellow LED, emergency light, how everything should be displayed in a single line. You've already seen it in the serial monitor earlier. So that's the whole purpose of this chunk of code. For the 4 remaining functions now, the first one is used to read the battery voltage. So the analog read gets a value between 0 and 1023, representing 0 volt and 5 volts at the analog pins. Since the battery might go up to 25 volt, a voltage divider is used to scale it down before sending it to the Arduino. So the formula is 25 times the value of the sensor, the voltage sensor, and then we divide it by 1023 to get the analog value back to the actual battery voltage. The second function now, the grid current, it's simply used to estimate the current in amps flowing from the grid using an analog current sensor ACS712. The current sensor outputs a voltage between 0 and 5, where 2.5 volt represents 0 amps, and the formula converts the raw analog value into a current value, scaling it between 0 to 10 amps. And the other ones is just a function to read the room light level from the LDO, and another function to check if the test button has been pressed. That was everything for this project. Thank you for watching this video.